Good afternoon, dear colleagues and guests. Today is the 26th of April, 2021, 3 p.m. Moscow time. Let me declare open a session of the Dissertation Council for the Defense of Thesis by Bazhanov, Pavel, Valerevich for the degree of Candidate of Physics and Mathematics, Specialty 051318, Mathematical Modeling, Numerical Methods and Program Complexes on Modeling of Acquisition and Correction of Positron Emission Tomography Projection Data. By the order of Academic Secretary of St. Petersburg University, Gniodov Alexander Valentinovich of the 12th of February, 2021, number 1111/1, me, Yegorov Nikolai Vasilievich, Doctor of Physics and Mathematics, Professor, Head of Department of Electromechanical and Computer Systems Modeling of St. Petersburg University, was appointed Chairman of this Dissertation Council. Other members of the Dissertation Council were appointed in the same order. Zhabko, Alexei Petrovich, is here next to me. Alexei Petrovich is honored worker of higher education of the Russian Federation, Doctor of Physics and Mathematics, Professor, Head of the Department of Control Theory of St. Petersburg University. In the remote access mode, we have Polozov Sergei Markovich, Doctor of Physics and Mathematics, Associate Professor of the National Research Nuclear University. Sergei Markovich, I understand you can hear us, right? Yes, I can hear you perfectly well. Excellent. And Dr. Georg Müller, Technology Institute of Karlsruhe, Germany. Yes, I can see and hear you. Our Dissertation Council, according to the order, consists of 5 members. And Yevgeny Igorevich Veremey was supposed to be with us, but unfortunately, it's a disaster for our university. To our deepest regret, he is no longer with us. And of course, the degree applicant, Bazhanov Pavel Valerevich, is here with us, who is ready to defend his thesis. Also, the academic advisor of the applicant, Elena Dmitrievna Kortina, Doctor of Physics and Mathematics, Associate Professor of the Management Theory Department of St. Petersburg University. To improve the quality of connection, dear colleagues working in the remote access mode, please switch off your microphones, but please remember to turn them on when you're given the floor. Let me also inform you that our session is being broadcast online at St. Petersburg University website. The speeches are being simultaneously translated from Russian into English or from English into Russian. During the live broadcast of the Dissertation Council session, an email is currently displayed, to which, during this session, all the listeners may send their opinions and questions to the applicant online regarding his thesis and the ongoing scientific discussion. These questions shall be forwarded to me by our technical support department, and I shall present them during the discussion part. Questions should be related strictly to the applicant's speech and the content of his thesis. It's necessary to include full name, position, and place of employment of the author of the questions. Questions that are not related to the ongoing scientific discussion, the text of the thesis itself shall not be presented. According with the order of awarding degrees of Candidate of Science and Doctor of Science at St. Petersburg University, approved by the local regulation of St. Petersburg University, a session of the Dissertation Council shall be considered competent if at least 2/3 of the appointed members are present, but not less than 4 persons. Our Dissertation Council consists of 5 members, 5 are present, including 2 council members working in remote interactive mode. Audio-visual contact has been established with all the council members. Thus, we have the quorum. let me set forth the following procedure of today's session, with approximate duration of 2 hours. First, a summary report of the chairman on documents submitted by the degree applicant and their compliance with applicable regulations, answers to possible questions, approximately 5 minutes. Second, summary report of the applicant outlining the key findings of his research, approximately 15 minutes. Next, questions to the applicant strictly on his report, no more than 2 minutes per each question. Number 4, answers of the applicant, no more than 5 minutes for all the questions. Number 5, speeches of all the council members in turn, with their assessment of the thesis, and the applicant's speech, with a summary of their opinions, questions, and suggestions to the author. Approximately 10 minutes for each speaker. Number 4, chairman's speech with his assessment of the thesis, approximately 10 minutes. Number 7, answers of the degree applicant to questions and comments made by the council members, no more than 10 minutes. If council members decide, we may ask the applicant if he doesn't mind to answer questions asked by the council members right away after each review is presented. What is easier for you? Yes, it will be easier for me to answer each reviewer individually. Number 8, open discussion of the speech and suggestions, not only of council members, with summaries of their opinions and or specific suggestions to the applicant, strictly related to the topic of the study, no more than 5 minutes. At that, all the speakers are kindly requested to register themselves in advance and introduce themselves before speaking. Number 9, presenting questions to the degree applicant sent during the discussion and the ongoing scientific discussion during the live broadcast of the council session at St. Petersburg University website. Number 10, answers of the applicant. The academic advisor's speech, no more than 3 minutes. Number 12, discussion by the council members before the open voting of the defense results. For that period, the sound shall be switched off, approximately 5 minutes. 13, open individual voting. The chairman shall count the votes, and the results shall be recorded in the minutes of the meeting. Number 14, making a decision on awarding or not awarding the degree and to the applicant, and closing remarks of the applicant, no more than 2 minutes. Dear colleagues, do you have any questions or objections to this procedure? Georg, are you okay, dear colleagues? Are you okay with this procedure? No, we don't. Okay, then let me start our session. But before I do that, please switch off your mobile phones. Thank you for your understanding. Well, let us start our session with my summary. A thesis by Bazhanov, Pavel Valerevich, for the degree of Candidate of Physics and Mathematics, specialty 051318, Candidate of Physics and Mathematics, for the Candidate of Physics and Mathematics, the topic mathematical modeling. It's the name of the modeling of assembly and correction of projection data of positron emission tomography was accepted for defense by the order of Academic Secretary of St. Petersburg University, Gnodov Alexander Valentinich, on the 2nd of February 2021, 800/1. Bazhanov Pavel Valerevich wrote his thesis at St. Petersburg University. His academic advisor is Doctor of Physics and Mathematics, Associate Professor of the Management Theory Department, Kotina Elena Dmitrievna. I beg your pardon, but for repeating myself now. Something I have not mentioned before. The number of publications of the applicant which set forth the main scientific results of his work according to the enclosed list is 13. In peer-reviewed scientific journals from the list approved by the Ministry of Science and Education of Russia, 3 publications. In publications indexed in scientometric databases, Web of Science and Scopus, 4 publications. The degree applicant submitted to the academic secretary Gnodov Alexander Valentinich a full set of documents to accept his thesis for consideration and defense. All the documents comply with Article 12 of Section 3 of the order, approved by the rector of the university. All the documents submitted by the applicant, according to the information are received from the curator, comply with the regulations, and are kept in the applicant's attestation file. Copies are available from the officer of the Dissertation Council Activity Support Department, who is currently present. Karpova Natalia Vladimirovna is present. Before I give the floor to the applicant, let me ask you, dear council members, if you have any general questions to the applicant, and is it necessary to disclose and review the entire list of documents submitted for defense? No. I thought so. There are no questions. Pavel Valerevich, the floor is yours. Let me remind you that you have 15 minutes. Questions to the applicant, please, should be related strictly to his presentation. Dear Pavel Valerevich, welcome. Good afternoon, dear council members. Please speak up a little bit. My name is Bazhanov Pavel Valerevich, and the topic of my thesis is assembly and correction modeling. The work consists of introduction, 5 chapters, list of terms, and conclusion. The first chapter is dedicated to the subject of this study. The second chapter is dedicated to data modeling and assembly and impact on the quality of images. Chapter 3 and 4 are dedicated to methods of scattering collection, and in chapter 5 I suggested movement correction method, a movement correction based on speed field. Modern medical diagnostics include various tomographic methods such as CT, MRI, PET, etc. All these methods make it possible to obtain images of internal anatomy of patients. Such methods as SPECT and PET also allow obtaining information on functional measures. PET method is widely used to study the biological processes in the patient's body, such as metabolism and transport of substances and other processes. This method makes it possible to detect a disease at its earliest stage, which is especially important in diagnostics of such diseases such as malignant tumors and Alzheimer's disease. Images obtained with PET technology are carried out together with other types of studies, and their accuracy depends on a number of factors. The main factors include absorption of radiation with photographic effect and quantum scattering, also accidental coincidences. The quality of images affected by patients' movements during the exam test. Thus, data collection simulation is a relevant task, as well as correction of these factors. Thus, the aim of my work is to develop a set of programs for simulation of PET projection data acquisition, taking into account their main factors and their subsequent correction. So the following cell, we analyze existing methods of modeling and collection and correction of projection data. An algorithm and its software implementation were developed, and of random coincidences during the registration of radiation, of gamma quantum, and algorithm of. Also, we developed a method of velocity field to scientific novelty. So the patient affecting the quality of images developed programs for correction of scattering and accidental coincidences. We also developed a method for velocity field construction of radionuclear. So the PET method, before the study, patient is injected with a preparation labeled with a radiative nuclide that decays with emission. After a free run of no more than a few millimeters in length, the positrons annihilate with the tissue electrons, forming pairs of gamma quanta directed. After passing through tissues of the recorded by detection equipment, is a position computer with the main effects, so the main types of interaction between radiation and this photographic photo effect and Compton scattering. Each event is characterized with a time label according to unique events list, and each pair of detectors has its own response line. During scanning, the information is collected about coincidences along each response line, and these are called PET data. This is the two-dimensional mode is the arena of detectors, separated by collimators, gamma quantum, the angle of which is very different from which makes more sensitive of scanner detectors, but at the same time the number of accidental coincidences also increases. In PET there's authentic coincidences and accidental coincidence, registering quantums from different annihilation events. The time period is the coincidence time window, collection method. So we propose taking into account the main factors which affect image quality and data collection, the sensor configuration, and in the end we obtained results. Also, we were able to preserve for future analysis and study. This diagram of this slide illustrates this method, and in this slide you may see the main formulas used for this algorithm. So this algorithm was implemented in C# language, and the results of its operation are shown here. We may see from different radiation sources and different collection methods. Thus, the results of Chapter 2 developed an algorithm of PET data collection, considering weakening and scattering of radiation, and created a software. And this program was registered in a registry of software products. The projection data, the first algorithm, was based on Monte Carlo method. It is based on analysis of images reconstructed from projection data. Thus, the entry parameters, or information about detectors and density, and we get output data. This method of scattering consists of the following steps shown here, and assessment of each response line was evaluated as follows, as shown in this slide. This algorithm was also used, created with C# language, and this slide shows the results of its work. So we may see the correction before and after correction. The second method was based on registering. So the input data was PET projection data, information about energies of registered gamma rays obtained by data collection simulators. So in output, we obtained projection data. Elements of probability table were calculated using the formula in this slide, and further correction was made. So this algorithm was also used, and this slide shows the results of his work before and after correction. In our work, we implemented two random coincidence correction methods. First was based on deferred window method. This slide shows sinogram before and after correction, sinogram of accidental coincidences. And the next algorithm, based on estimation of random coincidence rates. So we measured velocity of registering unique events by the detector. So the speed of accidental coincidences was measured, and correction of projection data was performed. The results are shown here. The results of chapters 3 and 4. We developed algorithm based on multicolor and analysis of registered coincidences, and tested on deferred window and speed of accidental coincidence, and summarized results of correction methods. Creating a velocity field. So we optimization algorithm for construction of the velocity field, which can be used for motion correction. Motion correction in radionuclide studies. This algorithm is based on a variation of the integral functionality in the problems of controlling ensembles. So we will consider the system of differential equations, and will assume that was carried out by system 1. Let's introduce a function of density as a function of distribution of preparation. So plays the role of density, charge, and in this task, this function plays the role of qualitative characteristic. For example, as how bright. As with a given f function, the equation it looks as shown in Formula 2 in this slide. Let us set initial condition 3 and define this. So this is a set of initial values. Let's call ensemble a set of solutions of system, and mtx as in section shall be called cross section. So let x is a known brightness at time, as also rho is known after delta t after some time. So it's necessary to find a vector of parameters such as u, so that time density in equations 2 and 3 coincided with density. With this purpose, Thus, once we found the u vector and having determined function f, we can create velocity field. With this purpose, we shall restore parameters of vector u, and we shall use the method of shown in Vladimir Ovsyannikov's works. Let's introduce a new function. The variation of functionality 7 has the form of 8, where psi and lambda are subordinate supplemental functions, and 10 with final conditions of 11. The expression 9 can be used as for optimization algorithm of velocity field, and on the basis of this equation, various methods of guided search of parameters. From equation 2, we may deduce that a product of distribution is described by equation 12, and solution to equation 12 with initial condition 13 can be represented as 14. As mentioned earlier in image processing problem, the type of function f is such as, so then line coefficients will create the u parameter vector as a linear function as shown in equation 15. And then components of u will be matrix A and vector C. Thus, having found vector u, we can create the velocity field. And on the variation 9, it's possible to obtain, we may obtain a gradient of a vector C. As gradient components are shown in equation 16. Equation 10 will take the following form. Equation 17 with finite conditions 18. And based on these formulas, an algorithm for constructing the velocity field was developed, and the algorithm is shown in this slide. Implementation of this algorithm was octave language. The results, in case of two-dimensional image, the proposed algorithm can be considered as a new algorithm for determining the optical flow. And the slide shows the results of application of this algorithm for motion detection of images in dynamic nuclear medicine. So here, in the case of optical flow, the velocity field has been created. It's marked by errors on this image. When the case of neo-optic, non-optic flow can also be used in nuclear medicine. This slide shows redistribution of radiopharmaceuticals for two images of hepatobiliary system. A resulting velocity field is depicted by arrows. In case of three-dimensional image, we considered for tomographic PET images, construction of velocity field is visualized on corresponding sliders. So you can see before this method could be used for correction of tomographic images, and in the work we compared the results of this method of Lucas Canada method from the Library of Computer Vision, OpenCV, and the results were positive, which means in conclusion of chapter 5, a new algorithm for velocity field, and the results of computer implementation of this algorithm in cases of optical and non-optical flow. We compared work of the proposed algorithm and implementation of a Lucas Canada method. The main results have been presented at national and international articles and published 12. Obtained certificate of registration of a software product. This slide demonstrates publications on the topic of my study, and in conclusion, these are propositions submitted for defense, and this considering factors of algorithm to correct scatter and random coincidences have been developed. A new method for construction of velocity field for radionuclide image sequences for the case of optical non-optical flows has been proposed. A software implementation of proposed method of velocity field construction for 2- and 3-dimensional tomographic images has been developed. Thank you for your attention. Dear colleagues, do you have questions? Georg, do you have any questions? Yes, I do. I have 2 small questions, if I may. First of all, I don't understand in slide 12, where you, in the bottom, where you describe linear accelerator, why it has such an unusual form. Why is it so? Why is it not straight? Could you explain? Yes, thank you for your question. This slide, this image, shows sinogram for linear source, and data collection assembly for this was simulated considering weakened radiation weakened by absorption. So the source was not inside the detector ring, but was outside the ring, some distance away from this circle. So that is why the sinogram looks like this. Oh, I see. So it was not in the center. The source was not in the center. Well, in the first image, for cylindrical source located in the middle. I see. And then I have another question. This method, the Monte Carlo method, the correction of scattering, and the second method, they demonstrate that these cross-sections are different from those before correction, but is a correction of random coincidences. Both methods, slides 21 and 23, these correction methods have no impact on the result. The cross-sections look very similar to those obtained before correction. I can see no difference. Is this because the method is inefficient, or how would you explain this? The difference in cross-sections is for angles in sinogram. For example, 0 to 50 degrees, 125 to 80 degrees. After the phantom terms, there will be no coincidences. The even noise was removed from the sinogram. Oh, what shame. It would be interesting to see how your correction affects on sinograms. And last question, perhaps. In slide 26, where you showed your formula. How can you interpret in your own words once again a little bit more? Explain this equation number 2, slide 26. Question 2 describes the change of distribution density of preparation in space and time. So, in different settings, task settings, when divergence equals 0, get optical flow, and if trajectory is consistent. In case of divergence greater than 0, we get non-optical flow. I see. Thank you. Thank you. Georg, are you satisfied with the applicant's answers? Yes, I am. Thank you. Sergey Markovich, do you have questions? No. I have a small question, which maybe I will ask later. Yes, there will be time for discussion. Alexei Petrovich, do you have questions? No, I don't. I see. Then, well, council members have asked their questions, and let me inform the council members that we received one external review from Marushina Maria Yakovlevna, Doctor of Technical Sciences, Professor of Faculty of Management and Robot Techniques Systems. And with your permission, I will read the review. By Marusina. Contemporary trends in medicine based on complex diagnostic equipment such as PET tomography, single photon emission computers make a relevant development of mathematical models and software to increase accuracy of studies and quality of functional images. The work of Pavel Bazhanov is dedicated to algorithm and software for simulation of assembly and correction of positron emission tomography and correction of factors that affect quality of images. The thesis suggests a new simulation method of projection data that may consider various combinations of effects which have a negative impact on the image quality of images. The photographic Compton, such as Compton scattering, is common in registering radiation. The author also suggests a new algorithm for velocity field construction, images for optic and non-optical flows used for correction of movement in images. The thesis by Bazhanov is well structured, is a complete and relevant, has theoretical and practical significance. As a way of criticism, I would mention insufficient discussion of advantages of suggested assembly program of PET over other existing program complexes. But this remark does not affect the significance of this scientific work, and the author, Bazhanov Valerevich, deserves to be awarded the degree of Candidate of Physics and Mathematics, Specialty 05-13-18, Mathematical Modeling, Numerical Methods and Program Complexes, signed by Doctor of Technical Sciences, Professor of the Management Systems and Robot Techniques, Marusina M.Ya. Pavel Valerevich, will you please answer the critical remarks? I agree with all the remarks. Yes, maybe we could discuss them in more details, of course. And maybe later I will get back to this. Okay, maybe you will do that in your future research. Dear council members, now is time for us to present our reviews. I suggest the following procedure. First, I will give the floor to Georg. Georg, do you have any objection? Do you mind? Georg, do you mind? You do mind being the first speaker? My review is a little bit similar, but that's okay. That's okay. It's published at the university website, so you can give us a summary and focus on the key points only. Okay, I'll try to do that. Sergey Markovich, Please, you will be the second council member to speak, and the final review will be mine. Georg, the floor is yours. Thank you. The thesis by Bazhanov is dedicated to the problem of modeling of assembly and correction of projection data of PET. The work suggests and implements a method of modeling, simulation, or data collection, which takes into account various factor combinations which have impact on the quality. I'm not used to reading so much in Russian. The quality of images. The real implemented algorithm of correction and scattering and accidental coincidences during radiation registration. A new method has also for velocity field construction for further radionuclide images. For optical and non-optical flows and software implementation, obtained results have practical significance, practical theoretical significance, and could be useful for testing of new algorithm for correction of projection data, PET, and for design of correction equipment. And in conclusion, the thesis by Bazhanov corresponds to the main requirements, and the degree applicant, Bazhanov, deserves being awarded the degree of candidate of physics in this academic specialty. Thank you. Georg, maybe I missed. Do you have any critical remarks to the study? Well, I have maybe only one. What I didn't like, one thing I didn't like, where developed the modeling, a simulation algorithm for correction of projection data. Yeah, I have a critical remark here. In chapters 3 and 4, it would be good. It would be good to see a more detailed analysis of the results of the work and of produced software. It's described very briefly and very little interpretation. But this is not. This is not a critical drawback. This is not a critical drawback for my conclusion, my review. Thank you, Georg. Pavel, Valerevich, please answer Mr. Muller's remarks. Yes, I agree. Of course, I agree that results, qualitative evaluation, but in my presentation I presented cross-sections of these sinograms which illustrate the use. He agrees with your remarks and promised in his future studies to work on this harder, as I understood. And Pavel Valerevich, could you please speak up a little bit? Your presentation was quite clear, but when answering questions, you are your voice is too soft. Sergei Markovich, you have now the floor is yours. if you allow me, I will drop the formal part of my review. The thesis is dedicated to development of new Sergei Markovich, dedicated proof quality of collection of PET images, relevance, novelty, practical significance. Next, I touch upon the content, and while working on his thesis, Pavel developed a set of software that can improve image quality. The thesis is a complete piece on a high mathematical level, with all the necessary algorithm descriptions given. The results are well described in publications. Yet, I made some small critical remarks. The results of modeling reviewed only for cases, then the source of radiation is a cylindrical with fixed size and activity. Thus, we don't know how accurate these algorithms are when radiation source is complex. On page 32, it says, for correct work of algorithm, radiation intensity and in reverse centimeters, and the time of correction, how the size can affect correction of the algorithm. Third, on page 40, description of gamma quantum trajectory restoration, a picture could be given. And in chapter 3, there are no results of comparing in multicolor and registered coincidence method. There's no data on and there's no of time window method and accidental coincidences. But this remark coincides. But these critical remarks do not affect the practical significance and value of the work, and the thesis by Bazhanov Valerevich corresponds to the main requirements set by the order of St. Petersburg University, and the degree applicant Bazhanov Valerevich deserves to be awarded the degree of candidate of physics and mathematics. Thank you, Sergei Markovich. Pavel Valerevich, will you please answer the remarks of the council member? And please speak up. Thank you for your comments. So first, the modeling results was only discussed for cylindrical source of radiation, and maybe I should have given data for phantom of more complex configuration, and is not only of cylindrical but can be analytical, such as cylinder parameters or linear source as a 3D arrays, 3D sets with and modeling for more complex configurations is also possible. For example, in my presentation and work at figures 2.9 and 2.10 show results for linear source. So the sinogram, if we go back in my presentation here, the bottom picture on the left, that's a linear source, and on the right, these are 5 cylindrical sources put in a ring. So the more complex, the modeling of more complex radiation sources is also possible. As for the second comment about units of measurement as accuracy, I just mean that the correspondence of simulation data to data actually obtained by the tomographer. These were used to find this relation between physical measurements such as time and the use of other units is also possible, though it will be necessary to consider their relation. So that's what I meant by accuracy. And the comment on absence of data on accuracy and error. Yes, I accept. Yeah, but in my presentation, I have shown cross sections of sinograms to assess the algorithm performance. That's all I had to say. Sergei Markovich, are you satisfied? Yes, in general I am. Thank you, Sergei Markovich. Alexei Petrovich, you have the floor. Thank you. The title of the thesis well reflects its, so I'll skip relevance, the part on relevance, but novelty of results. I shall dwell on this. The work of Bazhanov suggests a method of in positron emission developed a software complex can be used for data assembly, setting coefficients, etc. And this software product was got registered as so it was properly registered. Also, new method of construction of velocity field for series of images that can determine and correct the patient's movement during the diagnostic tests. And as the number of publications is sufficient, as mentioned by the chairman, I shall skip the description of content, which was quite well described by the applicant. What I would like to say is that the thesis is a complete, relevant paper which has scientific value, questions and critical remarks. First, in the introduction, page 12, the author didn't have to give a full list of publications, but refer to the list of references in the end. In chapter 3, there's an image of sinogram or before and after correction of scattering, but it would be interesting to see qualitative comparison of the work of suggested algorithm. This is quite similar to another question. Question 3. The list of terms, for example, a sinogram could be explained. Next, there are some typos. For example, on page 66, fourth line from the bottom, so full, not its variation. Full function transformation instead of variation. Yeah, formula 519 on page 67 on the left, it is full functionality transformation, but the typo, and page 75 and describing the work of proposed algorithm. There is reference to work 57, but it's not clear what's the difference of the algorithm and the one suggested by the author from the algorithm described in this article, in this paper. But these critical remarks do not affect the overall positive assessment of the thesis, and I shall read the entire conclusion. As is the practice, the thesis by Bazhanov Valerevich on the theme Model and Assembly and Correction of Radiation Data of Positron Emission Tomography corresponds to the main requirements set by the order of St. Petersburg University and the degree applicant Bazhanov Valerevich deserves being awarded the degree of candidate of physics and mathematics academic specialty 051318, mathematical modeling, numerical methods, and software complexes. Article 11 has not been violated by the applicant, signed by me. Pavel Valerevich, will you please answer Alexei Petrovich's questions and remarks? Thank you for your detailed review, in addition to what was the above-mentioned absence of comparison of results of the work of performance of algorithm. You mentioned the list of terms and the term sinogram. Yes, I agree. For some reason, I missed this term. And sinogram term is a form of representation of projection data in shades of gray, where and is dislocation along the scanner central axis. There are some typos in these formulas, and from the context, it follows that in this formula there's a typo, there's a mistake. And the final remark about the difference between the algorithm described in 57, this paper. In this paper, the task of velocity field was addressed by introduction of Euler-Lagrange equation, the system of linear equations, and in this work we want to optimize the algorithm, and in this work it's possible to look at optical and non-optical flows. So there's no condition of brightness consistency. Is this all? Alexei Petrovich, are you happy with the answers? Yes, I am. Thank you. Dear colleagues, now it's the time for the chairman's review. The theme of the thesis by Bazhanov is certainly relevant, as the work suggests a relevant algorithm of correction of projection data, considering the various factors that affect the image quality, and implementation of this algorithm in a program complex for data assembly and correction. Besides, the author proposed a new method for velocity field construction, which could be used for correction of the patient's movements. The work has practical and theoretical significance. Undoubtedly, this software complex can be used for correction of new configurations of detection equipment, PE scanners, PET scanners. It's important that the author suggested a new method to measure the velocity field for a series of radionuclide images or optical and optical flows, and proposed its software implementation. Yet, I have some critical remarks, to be honest. So my first remark, in Chapter 1, the author mentioned methods existing software complex for collection of projection material data, but never analyzed how this data collection. Second remark, figure 5.1, construction of velocity field is based on optimization iteration algorithm. The question is how the initial values of parameter vectors are selected. Third remark, of gradient decline, page 72, but never explained its advantages. And finally, the work has some typos and punctuation errors. These remarks do not affect the overall high assessment of the thesis and the degree applicant, Bazhanov Pavel Valerevich, deserves to be awarded the degree of Candidate of Physics and Mathematics, Specialty 051318, Mathematical Model and Numerical Methods and Software Complexes. Article 11 of the above-mentioned order has not been violated by the author, and signed by me, Chairman of the Decision Council, Yegorov Nikolai Vasilievich. Pavel Valerevich, will you please answer the Chairman's remarks? Yes, thank you. With the first remark was about the difference between the developed software complex from the existing, such as complexes such as Gen 4, and its gate is actually used for modeling data in nuclear medicine, but its use is limited by the unique system, and in this software complex it is quite hard to tune, to configure. The software developed by the us can model data, PET data collection, considering factors that have impact on image quality. So the second question was about selection of initial values for the parameters vector. In this work, the initial value was selected as a vector with the zero component, but other variants are also possible. As for the selection of implementation of gradient decline method, this method is a method of rapid gradient decline, can measure extreme of this method is widely used in machine learning, and its main advantage is speed as compared with other methods, as well as the key reason was availability of this method in the Octave package suggested optimization algorithm. So this was my answer. Thank you. But about what about various unpleasant? So I hope you agree with my remarks about typos. I am satisfied with the answers to my questions. Dear colleagues, now we could, we may start a free discussion in which not only the council members but other attendees are colleagues who read our thesis online via the internet. If you don't mind, I will start this free discussion. In my positive review, I mentioned everything I wanted to mention about the thesis and the author, and I have only one question. In due time, I was a member of the board of experts where all the academic specialties were included, and I was a member of the board that our principal task, the main thing we included in the description of this specialty is that awarding academic degrees in this specialty is only possible who in his thesis complies with all the three titles: mathematical modeling, numerical methods and software complexes. And the thesis speaks well about numerical methods, and software complex has been created. So the first term, and the question: what mathematical models original were created by the applicant, or which known mathematical models were used to address the substandard or unusual tasks, problems? Is my question clear? Well, Georg asked about the equation number 2. It could be seen as a mathematical model. How original is this mathematical model? Has it been used before, or is this your original model? That was used before for other studies, and you applied it in this particular case. It's also true about the rest of mathematics that you have used. Well, of course, this equation is well known. The equation shows distribution of charged particles under the impact. Pavel Valerevich, when you answer questions, you speak so softly. Could you please speak up? I beg your pardon. It's necessary for Georg and Sergei Markovich to hear. This equation is widely used in tasks, electrodynamics, and so, of course, so this is not my equation. Yes, in electrodynamics it is used. But what you work on, this is not electrodynamics. You may say you use this equation to solve a different task. Can we say that? Yes, we used methods of optimization of charged particle rays for creation of velocity fields. I see. Well, thank you. That's enough. I finished my speech. Dear colleagues, do you want to add something? Maybe ask more questions. Alexey Petrovich Zhabko. Well, our Pavel Valerevich, I beg your pardon, Pavel Valerevich at Management Theory has been with us for a long time, since he was in his second year. And I just wanted to say that he is very hardworking. He's a good thinker, and these are his positive qualities. And also, when he took up the doctoral course, he was very focused. So you support, and from this side as well. Thank you, Alexey Petrovich. Georg, would you like to add something to what you have already said? No, thank you. I'm far away, so as my first encounter, I quite liked his presentation. I liked his paper. I enjoyed reading this paper, this thesis. So I don't have any additional comments. Thank you, Georg. Sergei Markovich, would you like to add something to you? No, not really. I agree with Georg. It's always a pleasure to read thesis which, in addition to the mathematical level, has practical significance and could be easily used not only for PET but for other analysis methods, etc. Thank you, Sergei Markovich. This was a very good addition. Natalia Vladimirovna, have we received any questions online? No, we have not. Well, then let's close the discussion part and let's give the floor to the academic advisor. Dear Helena Dmitrievna will talk about the applicant and his work. Thank you very much. I'm pleased to talk about this work, and Pavel, since we've known each other for a long time, since he came to our department, and that was a long time ago. He graduated our faculty, and the topic of his thesis, he got interested in this topic when he was a student. His first course projects, his graduation project, when he graduated, were dedicated to the study of positron emission tomography. And after Pavel successfully graduated, he took up the doctoral course, and he continued working on this as a doctoral student, and where he wrote this thesis. I also wanted to say that positron emission tomography is a radionuclide method, which is one of the most modern and promising examination methods. And it's so we are working in this field because data processing with the help of mathematical modeling in the sphere of nuclear medicine we've been doing at our faculty for a long time, and this is the first work on positron emission tomography and mathematical modeling methods that could be used in this critical sphere. Pavel always developed, he addressed one tasks from modeling, correction to correction of movement of patients' internal organs. And of course, the work has interesting and new models. First of all, there's a model for construction of the velocity field for various cases. And this model is new. The velocity fields were created and images processed for a long time, but with the help of such model, it was first time proposed by Pavel. Also, I hope that the developments in assembly, simulation, and correction will also be in demand, and we will use them in our educational courses. We have a master's course on applied mathematics and modeling for medical diagnostics, and maybe students will use the results, make good use of these results. And I also hope that the study of PET will lead to mass production of such scanners, and that will also be in demand. Pavel took part in numerous conferences, international and national conferences, since he was a student. And the latest conference where we took part together, to Professor Zubov, where we presented our paper. So I support Pavel Valerevich, I support his work, and I believe that it was done on a high level, corresponds to the requirements, and Pavel Valerevich deserves to be awarded the degree of candidate of physics and mathematics. Thank you. Thank you, Yelena Dmitrievna. Dear colleagues, do you have any questions to the academic advisor? No. Thank you, Yelena Dmitrievna. Dear colleagues, we are only 2 steps away from the conclusion of our work. First, what I have to say, since our session and some of our participants are council members and others present, or maybe the degree applicant himself, have any unanswered questions regarding working the remote access mode. If you have any such questions, please let me know. Georg, Sergei Markovich, no, we don't. Alexei Petrovich, no. Pavel Valerevich, no. Well, Natalia Vladimirovna, to make sure everything is done properly, while we listened to the academic advisor, have we received any questions by email? No. Now we must proceed to voting. The next item. We have 2 options. First, we may have a private discussion to discuss what was discussed, the applicant's speech, answers to questions, everything. But if we need this private discussion, if we don't, we may proceed straight to voting. So is it necessary? Do we need the private discussion to discuss any issues that came up during the council session, or shall we proceed? Shall we vote? Voting shall be open. Our chairman will ask each council member. Georg, do we need a private discussion? No, I don't think so. Sergei Markovich? No. Alexei Petrovich? No. I also don't think we need any private discussion. So let us vote. Council member Georg Müller, your opinion, please. Are you for or against awarding the degree? I am for awarding the degree. Thank you. Sergei Markovich, your opinion, please. I am also for awarding the degree. Thank you. Alexei Petrovich, your opinion? I am for awarding the degree. And the council chairman is also for awarding the degree. Next, I have the easy task to count the votes. And let me inform you that 4 council members voted for. No one voted against. And nobody abstained from voting. Thus, the decision of the Dissertation Council on awarding to Bazhanov Pavel Valerevich the degree of candidate of physics and mathematics, academic specialty, mathematical modeling, numerical methods, and software complexes, by the decision of the Dissertation Council, has decided to award to Pavel Valerevich Bazhanov the degree of candidate of physics and mathematics in the desired specialty 05-13-18. The decision was made unanimously. Thank you. And before we congratulate the applicant, let me once again ask the council members and the applicant and others present who followed as online. Do you have any remarks or any problems that we were unable to resolve? No. Thank you. Then let's give the floor to the applicant for his closing remarks. Thank you. First of all, I would like to thank my academic advisor, Kotnila Dmitrovna, for her time, for the opportunity to work on a really practical problem, to take part in development of several program complexes and other projects, and also though I finished my doctoral course a couple of years ago, we continued working together, and mostly thanks to Elena Dmitrievna, today's defense. She made today's session possible. Also, I'd like to thank the council members for their time, for reading my thesis and all the university staff who were responsible for the technical part. Thank you. Thank you. Because we have, and the council members, we have to thank Natalia Vladimirovna for the excellent organization of today's session. Thank you, Natalia Vladimirovna. And on behalf of the Dissertation Council, I congratulate Pavel Valerevich on successful defense and the decision by our council to award the degree of Doctor of Physics and Candidate of Physics and Mathematics. Thank you. We wish you lots of success and in the future. Well, dear colleagues, all I have to do now, after we finished our work, I declare our session closed. Thank you for your participation. Our external colleagues, Georg and Sergei Markovich, thank you very much for your excellent work, for participation, for your good questions and good discussions. Thank you, and let me wish you good health, which is crucial in our times. So I'm not sure what to call our pandemic life, but let me wish everybody good health. Thank you and goodbye.